All right, so in this video, I'm going to show you how to use polynomial division in order to find a slant asymptote of a rational function. Okay, so let's find any slant asymptotes. Okay, so let's say we have the function f of x is equal to x cubed minus 8 all over the quantity x squared minus 5x plus 6. Okay, so the first thing we want to do when you're looking for either a horizontal asymptote or a slant asymptote of a rational function is to compare the degrees of the numerator and denominator. So we can see on this one we have a degree of 3 in the numerator and a degree of 2 in the denominator. So the numerator has a degree that is exactly 1 larger than the denominator. Okay, degree in the numerator is exactly 1 higher than the degree of the denominator. That's what we need if we're going to have a slant asymptote. Okay, so now, in order to find the slant asymptote, we're going to divide these two functions. So we are going to take x cubed minus 8, but remember to put in your placeholders. So I'm going to put in a plus 0x squared plus 0x minus 8. So if you're missing any terms, put in a 0 as a placeholder. And then we're dividing that by x squared minus 5x plus 6. Okay, so then we just go through the same steps of polynomial division that we looked at before. So we need to think, what do we need to multiply an x squared by to get an x? Or, sorry, what do we need to multiply an x squared by to get an x cubed? And of course, the answer is x, so that goes in our quotient. All right, multiply the x by the entire divisor. So that would give us x cubed minus 5x squared plus 6x, and then we subtract. All right, so x cubed minus x cubed, those just cancel out. 0x squared minus a negative 5x squared would give us a positive 5x squared. 0x minus 6x would give us negative 6x, and then bring down the negative 8. Okay, and then we just do it again. So now we think, what do we need to multiply an x squared by to get a 5x squared? And of course the answer is 5, so plus 5 in our quotient. And then we multiply the 5 by the entire divisor. And that would give us 5x squared minus 25x plus 30. All right, and then subtract. So 5x squared minus 5x squared, those cancel. Negative 6x minus a negative 25x would give us 19x, or yeah, 19x. And then negative 8 minus 30 will give us a negative 38. Okay, so that's as far as we can go. X squared cannot go into a 19x, so we're done. Okay, now when we're looking for a slant asymptote, the only thing that matters is what's in the quotient. Okay, doesn't matter what's in the remainder, you can just kind of ignore that, it's irrelevant. Only focus on what's in the quotient. So in this case, we can see that our slant asymptote is y equals x plus 5. And that's our answer. Okay. All right, let's go ahead and look at another example. Say we have f of x is equal to, let's do 8x squared plus 26x minus 7 all over the quantity 4x minus 1. And again, we're trying to find our slant asymptote if we have one. All right, so once again, we start by comparing the degrees in the numerator and denominator. We can see that we have a degree of 2 in the numerator and a degree of 1 in the denominator. So degree of the numerator is exactly 1 higher than the degree of the denominator, which means we have a slant asymptote. Okay. All right, so we're going to go ahead and divide 8x squared plus 26x minus 7 by 4x minus 1. All right, focus on the first term of the dividend and the divisor. And we'll ask ourselves, what do we need to multiply a 4x by to get 8x squared? Of course, the answer is 2x, so that goes in our quotient. So then multiply 2x by the entire divisor. That would give us 8x squared minus 2x, and then we subtract. So 8x squared minus 8x squared, those are going to cancel out. And then we'll have 26x minus a negative 2x would give us a 28x, and then minus 7. Okay. All right, do it again. So what do we need to multiply a 4x by to get a 28x? Of course, the answer is 7. So plus 7 goes in our quotient. And then multiply 7 by 4x minus 1. So that would give us 28x minus 7. And subtract. Okay. So 28x minus 28x, those cancel. Negative 7 minus negative 7, those actually also cancel. So this just leaves us with 0. Okay. All right. Like I said, though, the remainder doesn't matter. Just focus on what is in your quotient. In this case, we have a 2x plus 7. So that tells us that our slant asymptote is at y equals 2x plus 7. Okay. All right, guys. So that is it for slant asymptotes. So basically, if you have a rational function where the degree of the numerator is exactly 1 higher than the degree of the denominator, go through your steps for polynomial division, and your quotient is your slant asymptote. Okay. If the degrees work out in any other way, so if the degree on top were smaller than the denominator, if the degree on top were equal to the denominator, or if the degree on top were more than 1 bigger than the denominator, then there is no slant asymptote.